Today I want to talk to you about triangles. So we've already had a look at angles, but now it's time to move on to having a look at a triangle. So some of the things we need to know about triangles is how to name them. We need to know how to classify them according to their sides and their angles. And of course there's lots of interesting facts about triangles to learn along the way. So let's start by how we might name a triangle. So we use the same sort of technique that we use for naming angles, in that we have a triangle and we label the corners or the vertices with capital letters, like that. Now if I wanted to talk to you about naming this angle, I would call that angle CAB. But if I want to talk about the whole triangle, I need to use a different symbol. I need to use this one, triangle, CAB. And that's why those little symbols out the front are really important, so you can tell whether we're talking about just an angle or talking about a whole triangle. Now, of course, I could have also called this triangle BAC. It doesn't really matter what order you put those letters in, as long as you've got all three corners marked for the triangle. Now, we can also label the sides, which is useful in triangles. So the side that's opposite a particular angle gets the same letter, but in lowercase. So that's going to be side A, and this one is going to be side B, and the one opposite here will be side C. So we use little letters for sides and big letters for corners. So interesting to know that. You might also notice that the longer side is opposite the largest angle, and the smaller side is opposite the smallest angle. Makes sense if you think about it. We can classify triangles lots of different ways. Well, two really. This one is to do with the side length. So for a scalene triangle, they're triangles that have all three sides different lengths. So they might look like this, where this side and this side and this side are all different lengths. Isosceles are special in that they have two sides that are equal in length. So we can mark those two with the same markings, and the other side is a different length. What's also special about that is that these angles down here are also equal. They're called the base angles, and so we know that the base angles are equal. When it comes to classifying triangles by their sides, we use these three terms: scalene triangles, isosceles triangles, or equilateral triangles. So let's start with scalene. Scalene is just your average garden variety, boring old triangle. Nothing special about it at all. All three sides are different, so we can put markings like this on the sides to show that all sides are different lengths. Whereas isosceles triangles are a little bit more special because they have two sides that are equal and the other one that's a bit different. So these sides here are equal, but this one here is different. Now the other thing about an isosceles triangle are not only the two sides the same, but these two base angles down here are also the same length. So that's what makes an isosceles triangle special. They've got two sides and two base angles equal. Now, that brings us to equilateral triangles. Now, equilateral triangles, as the name suggests, have all three sides equal in length. So we can put some markings on them to show that all three are exactly the same. And not only are all three sides the same, but all three angles are also the same. And that's why it gets that name of equilateral. So 3 sides and 3 angles are the same. Another way of classifying triangles is according to their angles. We've learned a bit about angles already, so we know an acute angle, for example, is an angle that's less than 90 degrees. A obtuse angle is between 90 and 180, and a right angle is a 90-degree angle. So we can name triangles according to those features. So, for example, an acute angled triangle has all acute angles. So we don't really care about the sides so much here, just that all of those angles are less than 90 degrees. That's what makes an acute angle. So all angles are less than 90 degrees. Now when it comes to an obtuse angle triangle, they're the ones that have one angle that's obtuse. They're kind of going to lean on them like that. So this angle here is clearly an obtuse angle. So they have one obtuse angle. You can only ever have one in a triangle because otherwise you can't draw up the edges to make it into a triangle. The third type then, right angled, well that's pretty straightforward. It's got to have a right angle. So when we draw our triangle, it has to have that right angle in the corner. So it has one right angle, and the other angles are acute angles of some sort. Now, interestingly enough, the angles in a triangle will always add up to 180 degrees. And that's one of the reasons why we can only ever have one obtuse angle in a triangle, is otherwise they would add up to more than 180, and then you couldn't build a triangle. So now here's a challenge for you. You can combine all of those descriptions together sometimes. So I want you to have a go at drawing a right-angled isosceles triangle. Make sure you put all the symbols on there to show that it's a right angle and show that it's isosceles. And the last one, is it possible to draw a right-angled equilateral triangle? Well, that's something for you to ponder.